IP version 6 is the new version of Internet Protocol, which is way better than IP version 4 in terms of complexity and efficiency. IP version 6 resides at the network layer similarly to IPv4. It has a larger address space compared to IPv4, in where the addresses are 128 bits compared to 32 bits. The addresses are represented in hexadecimal notations. It's a connectionless protocol, which means it's a best effort protocol. It doesn't use broadcast, but it uses multicast instead. As you will see in the next slide, it has fewer header values. It needs ICMP version 6 to operate. Let's compare IPv4 and IPv6 headers. IPv6 header are much simple than IPv4 header. We don't have the header length. We don't have any fields related to fragmentation, such as identification, flags, and fragment offset. We don't have the header checksum. The hop limit in IPv6 header is just another name for TTL, or time to live. We will see a lot of IPv6 data on our networks, so it is better to get equipped and familiar with it. The header sizes are shown here. We have 4 bits for version, 4 bits for traffic class, which is just another term for quality of service, 20 bits for flow label, payload length is 16 bits, next header is 8 bits, hop limit 6 bits, and the source and destination addresses are 128 bits. Let's go to Wireshark directly and inspect the IPv6 header. In the display filter, type IPv6 and just press enter. Make sure to expand the Internet Protocol version 6. The first field indicates the version, which is again a 4-bit field that contains a bit sequence. So here the value is 2 plus 4, which is 6. The traffic class field indicates class or priority of IPv6 traffic, which is again similar to service field in IPv4 packet. It helps routers to handle the traffic based on priority. The value of 0 is a best effort. The value of 1 indicates that the data is background data. Value of 2 indicates that the data is unintended data traffic. Value 3 means reserved traffic, and so on and so forth. We will not go into the details of the types of traffic. Flow label field is used by source to label the packets belonging to the same flow in order to request some special handling at the receiving end. Payload length is a 16-bit field. It indicates the total size of the payload, which tells the router about the amount of information following the IP header. The information following the IP header here is ICMP protocol v6. If we click on that, we'll see the size down here, 24 bytes, and the value is 24 bytes. The next header indicates the type of extension header, if it exists, and in some cases it indicates the protocol contained at the upper layer packet. In this case, it is ICMP v6. It can be TCP or UDP. Extension headers are an approach used by IPv6 just to rectify some limitations compared to the IPv4. We can have extension headers on top of the IPv6. This is mainly used for security and encapsulation purposes, but for the sake of this course, we will not dig into that. Hop limit is the same as TTL in IPv4. It indicates the maximum number of nodes an IPv6 packet is allowed to travel. And last, we have the source address and destination address, which are 128-bit addresses or bits addresses, indicating the source and the destination of the packet. I've just pressed on view and packet bytes to show you how does the 128 IP address look like.